The James Webb Space Telescope is not just showing us distant galaxies. It's exposing the cracks in our most cherished understanding of reality. What happens when discoveries from the edge of the cosmos begin to challenge the very laws of physics themselves? Until now, physics has relied on the idea that certain quantities, like the speed of light, the strength of gravity, or the charge of an electron, are constants, immutable, unchanging. These constants are the bedrock of the universe, defining how matter behaves, how stars burn, and how galaxies evolve. But what if they haven't always been constant? The early universe, as observed by JWST, is not behaving the way we expect. Galaxies are forming too quickly, masses are building too early, and structure is emerging in apparent violation of our cosmological models. One possibility, among the most radical yet scientifically intriguing, is that the laws of physics themselves may evolve over time. This idea is not entirely new. Physicists have long speculated that certain fundamental constants could drift under extreme conditions or across cosmic timescales. The fine structure constant, for example, which governs how light and matter interact, has been tested in distant quasars. Some results suggest it might vary slightly across space or time. If true, even a tiny variation in this constant in the early universe could result in massive differences in how atoms formed, how stars ignited, and how galaxies took shape. Then there's gravity. We think of gravity as the weakest but most far-reaching force in the universe. It governs the motion of planets and galaxies, but current models assume that its strength has remained the same since the beginning of time. Now, some theorists propose modified gravity theories, like FER gravity or scalar tensor models, where the gravitational constant is not constant at all, but dynamic. In these models, gravity may have been stronger or weaker during the universe's infancy, allowing matter to collapse faster and structure to form earlier. This could explain how those massive galaxies observed by Webb could arise so quickly, without rewriting every other aspect of the Big Bang theory. But it goes deeper still. Some scientists believe that space-time itself might have behaved differently in the early universe. In emergent gravity frameworks, gravity isn't a fundamental force, but a product of thermodynamic or quantum information processes. If that's the case, then early space-time might not have even followed the same rules of curvature and causality we observe today. In other words, the early universe may have had its own physics, now hidden beneath the veil of cosmic history. Could this be why we're seeing galaxies that shouldn't exist? Could their formation be governed by temporary laws, a different rule book during the universe's chaotic birth? If this is true, it would mean that the laws we observe today are only local approximations, a kind of cosmic consensus formed after the early chaos settled. And this raises a chillingly beautiful possibility that the universe is not a machine running on eternal rules, but a living system with evolving principles. A cosmos that breathes, shifts, and grows, not just in scale, but in law. Of course, these are bold ideas. Changing the laws of physics is not something science does lightly. It demands overwhelming evidence, extraordinary rigor, and a complete rethinking of centuries of theory. But the cracks are showing. From the nature of dark matter and dark energy to the unexpected abundance of early galaxies, the cosmos is revealing a tapestry far more complex than we imagined. At Infinity Beyond, we don't claim to have the answers, but we do believe in asking the right questions, especially the ones that make us uncomfortable, the ones that push us beyond what we thought was knowable. Because history shows that physics breaks right before it breaks through. In our next segment, we'll explore what lies ahead, the future of astronomy in a post-Webb world. How will upcoming telescopes, particle experiments, and AI-driven simulations reshape our search for cosmic truth? And could the next discovery be the final key to rewriting reality itself? Stay with us. The universe has much more to say.